Hi everyone, for this question given, the function of fx is equals to log 3 2x plus 1 and find the inverse function. Hence, sketch the graph on the same axis, state the domain and range for the function and the inverse function. First of all, we find the inverse function by using composite method. So the method of equals to y and let x, that one is the old method, so we not recommend anymore. So in this level, you must find your inverse function by the concept of composite. So if you want to find f inverse, means our composite method will be start with f inverse equals to x. So we're going to substitute our f inverse into our function f, where this x will be replaced by f inverse. So you have f inverse. Then this one will equals to log 3 and then 2 times f inverse plus 1 equals to x. So what we need to do is simplify this and find out what is our f inverse. First, we unlock this log, let the base 3 to the right hand side. So 3 will go into power of x. Then we move our 1, become 3x minus 1. Then finally our f inverse will be 3 power of x minus 1 over 2. So this is our f inverse. Then we want to sketch the graph on the same axis. So means sketch our function and inverse function on the same axis. When we want to sketch the inverse function, we need to use the concept of reflection. Always sketch the original function, then reflect on the axis of reflection y equals to x to get the graph of inverse function. So to draw this graph, what we need is starting from domain and range so that we can know where's the location from the graph and orientation for the graph. For the domain of the function, whatever log brings here, it must be positive. So x will be greater than negative 1 over 2. So in the interval form, negative 1 over 2 to infinity. So from here, actually we can note that x equals to negative 1 over 2, which is not included into our value, is a asymptote. Then when we come to the range of the function, log is not a special case, so it always get negative infinity up to infinity. So in this case, we know that this graph is going to the right. So asymptote going to the right. So log graph is a bentuk of tiang lampu, lamppost, in the shape of lamppost. So whether this lamppost, this shape of log need to flip or not, need to terbalik or not, we will look at our function log. We don't have negative and our base is just integer, so we no need to flip it. So just as the shape of lamppost. Now we're going to set up our xy axis. Start to draw our original function fx with the asymptote here. X equals to negative half. Then we have our tiang lampu with the lamppost here get near to the asymptote, and then we want to start to shoot up. So when we want to shoot up, we have a problem that we're not sure whether we are intersect at negative part, or we should go higher, or we should go through the origin, we're not sure. And then one more, we're not only drawing for fx only, later on we need to inverse to get the f inverse. So we need our axis of reflection, which is y equals to x here. So when y equals to x come in, and our graph log want to draw here, we will have a problem. We need to concern that whether this graph will going higher than the axis of refraction or going lower than the axis of refraction. So to identify this graph, whether going above axis of refraction or below the axis of refraction, we need our calculator to help us to find out this figure. So for your understanding, axis of refraction, y equals to x. What's mean by this line? Which means that when your coordinate is 1, your y coordinate is 1. They are same. When your coordinate of x is 2, your y coordinate is 2, and so on. So 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 8, and so on. So we use calculator to see what happened to our graph. We want to see their coordinate, how high they're going to go, and or will be below the axis of refraction. We take the mode, go for the table. We put our function here, which is the function that we want to draw here, log graph in the base. So it will be log base 3, and then that will be 2 alpha x plus 1. So we insert this function. Start value, we want to start it from negative half. So end value, so we're going to the right hand side here, let's say across 0, 1, 2, maybe we put 2 or 3. And then step. Step means selang dia, the gap between each coordinate. Maybe I put 0, 1. So when I put 0, 1 means my gap is too small. They have a lot of point they want to calculate. So this calculator, they have insufficient memory. So we need to reset this. So go back. So log. Start with 0 point. So maybe ending I take lesser. Let's say 2. Step I still get 0.1. Okay, so this time they can give us the coordinate coming out from this graph. So negative 0.5 error, of course, negative 0.5 is our asymptote. So our asymptote will not generate any graph, so it will not give you any y coordinate. Then you can go and see when you're negative 4, it's going up, negative 1, negative 0.3, negative. So going up, so negative 0.1 here, negative 0.2, the coordinate. So when you come to see 0, 0, so you know that here we have a hint that when you come to origin 0, the y coordinate is 0. So their intercept is at 0, 0. Then continue. When you go in 0.1, your coordinate 0.1 and more. So your means your graph is getting higher than the refraction axis, because refraction axis, if you have 0.1, refraction axis only 0.1. So now you have more than 0.1. The coordinate here more than means your graph will be getting over the refraction axis. So before that, you can see negative 0.1, it gets still lower than that. So after 0, it's getting more than that. So this coordinate getting more. So 0.4, 0.5 means when I come to this 0.4, my graph is 0.5. It's getting higher than the refraction axis. Refraction axis just 0.4 only. So you can see 0.5, 0.6, getting higher, getting higher, getting higher, getting higher. And then when you come to a point where 1 means it's touch back your refraction axis. So when you want 1, touch back your refraction axis, and then they start going lower. When your coordinate is 1.1, your y coordinate become lesser than 1.1, become 1.05, means your graph starting lower than your refraction axis. And then you can see 1.1, the graph become 1.2. When you 1.3, your graph become lower 1.1, and then 1.2, 1.5. So as long as your graph is going to the right, your graph, the y coordinate of your graph is getting lower than the axis of refraction. So from here, which means that when we drawing the graph getting near to the asymptote, then when you want to shoot up, remember just now shoot up, at the beginning, we are over the axis of reflection. Then when we going to the right, it's getting lower and lower. So our graph coordinate here is getting lower, then the value of x means it will getting lower than the reflection axis. So we can go through one more time. Look on beginning here. When you have negative 0.5 error is asymptote. When you have negative 0.4, it is more negative, means it's more lower. Then negative 0.3, negative 0.8, more lower than your axis of reflection until to the point they're getting same is 0, 0. So here is our intercept, 0, 0 label. Then, but after 0, you can see our graph is more than your x-axis, x-coordinate already. So means your graph is getting higher than your reflection axis. Then 0.1, you can see 0.1 is getting higher, 0.2 getting higher, 0.3 coordinate, you can see the graph is getting higher, 0.4, 0.4 getting higher, 0.67, then until the point of 1.1, it start coming down. When you 1.1, this one just 1.05. When you have 1.3, this one just 1.165. So that's why our log graph is going cross over the axis of reflection. Then after the shooting, for the bigger value of x, they start coming down below than your axis of reflection. So we must get a correct fx, then only we can do the reflection to get the inverse function from the graph correctly. So the next part we're going to do is we're going to inverse it. So how to inverse it? Firstly, from the vertical asymptote, where it touch this vertical asymptote, touch the axis of reflection here. So from here, our image of reflection will become up. Make sure you do it correctly. Let's say this is your vertical asymptote, this is your reflection axis. So at here, you will get your image of reflection. Alright, so don't do like this. Let's say this is your thing. When you want to refract, you just simply draw a horizontal line like this. So that is wrong, because when you touch this axis of reflection, supposedly here to be happen your reflection. It's not here. Alright. So refract at the place where your object touch your axis of reflection. So when your object touch the axis of reflection here, so here is the image coming up. Then continue. Alright, so I do this part first, refract this symmetrically. So here will be your anti, then you join back so you can see symmetry. How will be the symmetry? You can see my distance is almost same. Then after 0, 0, we have another curve here going up, refracted. So you can see if I draw here, alright, I do a demo. If I just simply draw like this, wrong. Why? Because I touching the effect. I touch the reflection axis here. So supposedly here is the place that we can come out the joining of the object and the image. The connection is happen here. It's not happen here. So make sure you get the joining correctly of the object and the image. So here we come our reflection image. So here it touch. So here the place we can get connected. Then finally we reflect out this part. So this is our another part. When this is our fx, means the reflected part here, the green color one, is a f inverse. So label our graph. After we draw this, we label our graph. Fx is equals to log 3 2x plus 1. So f inverse we already calculate F inverse, which is equal to 3x minus 1 over 2. Double check x-axis, y-axis, origin, vertical, horizontal asymptote. So vertical asymptote, when you refract, it becomes horizontal. It starts with y equals to negative half. Axis of refraction, so everything well labeled means this graph function and inverse function is done. Then we continue for this part. State the domain and range for the function and inverse function. So domain and range for the function we already done. So this is typo. This is supposed to be range. Alright, so domain of inverse function, it will be referred to the range of the function. So the range of the function will be negative infinity to infinity. Meanwhile, the range of inverse function, it will be referred to the domain of the function, which is negative half over infinity. Alright, so that's all. So if you're using new calculator, maybe when you want to key in the function, when you key in the function, you get gx, another function, you just skip you by entering the equal. So my calculator just can key in one function. The new calculator, they can key in two functions. Therefore, for the new calculator, two function, you just enter so that you can skip the function of gx that where we didn't use it. So that's all for these questions.